Nernst equation. We have assumed in the previous section that the concentration of all the species involved in the electrode reaction is a unity. This need not to be always true. Nernst show that for the electrode reaction, it's mean the concentration of reactions involving taken by one in Nernst equations. The electrode reactions is given by Mn plus aqueous form plus Ne is equal to metal in the form of solid. It's mean Mn plus means aqueous form of metal, n number of electrons. Or we can also say the transfer of electrons is electronic charge and its value is 1.6 into 10 power minus 19 coulomb. And Ms means metal which occurs in a solid form. Nernst equation for electrode reaction. The electromotive force of electrode reaction is equal to standard electromotive force of electrode reaction minus RT upon NF. Ln means log ln capital M upon Mn plus concentration. Here R is a gas constant, T is absolute temperature, and N is transfer of electrons, F is Faraday constant, and its value is 96,500. Ln means log, but a solid M concentration constant. So the expression can be written as into this form: electromotive force of electrode reaction is equal to standard electromotive force of electrode reaction minus RT upon NF ln 1 upon Mn plus concentration. For Daniel cell, for cathode, the electromotive force of electrode reaction is equal to standard electromotive force of electrode reaction minus RT upon 2F ln 1 upon Cu2 plus concentration. In this equation, the transfer of electron takes place in the reaction is 2, so we replacing N by 2. For anode reaction, the electromotive force of electrode reaction is equal to standard electromotive force of electrode reaction minus RT upon 2F ln 1 upon Zn 2 plus concentration. Cell potential means overall cell potential is equal to electromotive force of cathode minus electromotive force of anode. This is the general formula for calculating the cell potential. Electrochemical cell and gives energy of reaction. Electrical work done in 1 second is equal to electrical potential multiplied by the charge passed. If we want to obtain maximum work from a galvanic cell, then charge has to be passed reversibly. The reversible work done by a galvanic cell is equal to decrease in its Gibbs energy, and therefore if the electromotive force of cell is capital E and Nf is the amount of charge passed and delta G is the Gibbs energy of the reaction, then the relationship between Gibbs energy and electromotive force of cell is given by delta G is equal to minus N F E cell, where delta G is, as you know, Gibbs energy. N is the transfer of electron takes place in electrode reaction, and F is Faraday constant and its value is 96,500, and E cell mean electromotive force of cell. Law of independent migration of ion. It is also called as Kohraul's law. It states the law states that limiting molar conductivity of electrolyte can be represented as the sum of individual contribution of the anion and cation of the electrolyte. Thus, if lambda 0 Na plus and lambda 0 Cl minus are limiting molar conductivity of sodium and chloride ion respectively, then the limiting molar conductivity for sodium chloride is given by the equation. The molar conductivity of sodium chloride is equal to molar conductivity of sodium ion plus molar conductivity of chloride ions. In a Kohraul's law, suppose we have to calculate the molar conductivity of ZnCl2. In these molecules, first of all, we ionize in the form of Zn2 plus and 2Cl minus. So, the molar conductivity of ZnCl2 will be lambda 0 Zn2 plus 2 2 lambda 0 Cl minus, because in this situation the number of chloride ion is 2.